All right, so let's come to the section B of paper 1. We have given the velocity function. And we also have the time restriction here, that is 0 to 4. The very first question is find the value of t when the particle reaches its maximum velocity. So to find the maximum or minimum of any function, we differentiate the function. The differentiation of this function would be 8 minus 6t. So to find the maximum, I'll equate the differentiation, that is gradient function, with 0. And what I'm getting? I get t as 8 upon 6, which can be simplified as 4 upon 3. So to conclude that this is my maximum uh, velocity time, I will double differentiate to check whether it is coming negative or not. So when I double differentiate this function, the result is minus 6. When the double differentiation is minus 6, it means this is concave down curve, and that results into this t to give us the time at which the velocity is maximum. Part B, we need to sketch this curve, but this time we will not going to take the help of GDC. This is paper 1 question. So we will only doing this through the without calculator. So I'll just see the function, which is 3 plus 8t minus 3t squared. I'll find all the necessary things which we need to draw on graph, which is x-intercept, y-intercept. We already have the time at which this curve is maximum. We need to figure out the x-intercept and y-intercept. So for the y-intercept, I'll put x is equal to 0. So at x is equal to 0, y is 3. This will become 0 and this will become 0. And what is the value of t when y is 0? So I'll need to solve this, which can be written as 3t squared minus 8t minus 3 is equal to 0. We can do this with the help of middle term split. So I'm getting 2 times at which my y value is 0. One is 3t plus 1 is equal to 0. From here, my time will be negative, which will not possible. And from the other factor, I get t is equal to 3 seconds, at which my velocity will be 0. So I will mark my points here. So at t is equal to 0, I mean to say here x is equal to 0 is actually means t is equal to 0. So at t is equal to 0, the velocity is 3. It will start from here. And it is maximum at t is equal to 4 upon 3, which is something greater than 1. And it comes 0 at t is equal to 3. So it looks like this. This is that curve we can draw. Okay. Yes, sir. Am I audible? Hello. Am I audible? Hello. You are
Yeah.
mute.
Yes. Yes.
Am I audible?
Yeah. Yeah.
Did you get
Mm.
this answers that I'm doing?
Yeah.
But do one thing for this part C. Find the distance of the particle from the origin. That is, we need to integrate this function from 0 to 3. Do integrate this function. 3 plus 8t minus 3t square. Integrate this function. Let me know the result of this integration. How do you integrate 3 plus 8t minus 3t square? Do you know the integration?
Yeah.
Integrate that. 3 plus 8t minus 3t square dt. Integrate this function. Yes, what is the integration of 3 plus 8t minus 3t squared?
I'm still doing it.
If I use the power rule, the formula x raised to the power n dx, we integrate such function as x raised to the power n plus 1 over n plus 1 plus c, but of course you not need to use here plus c. This is the rule for integration of power function. The integration of 3 would be 3t, 8t would be 8t square upon 2, minus 3t square would be 3t cube upon 3. So it is 3t plus 4t square minus t cube. Putting the upper value, 3 times 3 plus 4 times 3 squared minus 3 cubed, minus putting the lower value, so it will be 0 plus 0 plus 0. So result is 9 plus 9 times 4, 36 minus 3 cubed, 27. So it comes out 18 meters. The distance traveled by the particle would be 18 meters. Did you get that?
Yeah.
All right, let's come to the next question, which is number 8. Question number 8 from sequence and series. Try to do this, give me the answer. The first three terms of infinite geometric sequence is given to us. Write down the expression for common ratio. What is the common ratio? U2 over U1. Second term is 4. And the first term is k minus 4. Right. Or R can be U3 upon U2. So when I do U3 upon U2, it will be k plus 2 upon 4 because U3 is k plus 2. Second is hence so that k satisfy this quadratic expression. So if I equate the both expression for the R, 4 upon k minus 4 equal to k plus 2 upon 4, we will able to generate this k value. I mean to say this expression. 4 times 4, k plus 2, k minus 4. Cross multiply. K times k square minus 4k plus 2k minus 4 times 2 is minus 8. So shift the position of 16 to the other side. Minus 4k plus 2k would be minus 2k. Minus 8 minus 16. Minus 8 minus 16 is minus 20. This is what they want us to do. This is the expression for the a which satisfies this equation. Now the second part is we need to solve this quadratic for finding the possible value of k. So I'll solve this quadratic k square minus 2k minus 24 equal to 0 to find the value of k. To use the middle term split, 6 times 4 is 24. So it will be k bracket k minus 6 plus 4 k minus 6. K minus 6, k plus 4 equal to 0. So what are the k values? K values are either positive 6 or negative 4. Positive 6 and negative 4 are the possible values of k. Are you getting this? So what are the possible R values? We have the two possible R values for one for minus 4, other for 6. So the R value would be, let's take one of the expression, 4 upon k minus 4. So k value is 6, so 6 minus 4, it will be 4 upon 2, which results into 2. And 4 upon minus 4 minus 4, which results into 4 upon minus 8, which results into minus 1 by 2. These two are the possible R values. One is 2, other is negative 1 by 2. 4. k is equal to 6 and k is equal to minus 4. Yes,
Yeah.
that's clear.
Yeah.
Let's come to the C part. The geometric sequence has infinite sum. So this is infinite GP. For which value of R leads to him to this sum. So we know that for infinite GP, my R value should be from -1 to +1. This is the only condition for R to be to make the sequence infinite GP. So it means what? It means out of these two R value, which one will qualify for this infinite GP? One which is having value in between -1 to 1. So this 2, the value of R having a value greater than 1. So it will not qualify it for infinite GP. So I'll take R as -1/2 as my R value for this sequence to be infinite GP. Are you getting this?
Yeah.
Now, what is the sum of the infinite GP? What is the formula? S infinite is U1 upon R minus 1. Or we can say that U1 upon 1 minus R. This is the infinite GP sum. U1. So what is the U1? U1 is K minus 4. U1 is K minus 4. And what was the K value? K value was either -4 or +6. The K value was either -4 or +6. So at which K value the R value is -1/2. For K value -4, the R value is -1/2. So I'll take K value -4 to get my first term, which is -8. So U1 is -8 over 1 minus -1/2. So it is -8 over 1 plus 1/2. So -8 upon 3 upon 2. So it is -8 times 2 upon 3. This is -16 upon 3. So -16 upon 3 is the value for S infinite.
Yeah. I got it.
Let's take the last question of this paper 1 and this section B, that is number 9 from probability. What is the meaning of without replacement? Without replacement. This is the case of without replacement. It means that whatever things you are taking out from the bag or from the container, you are not putting that things back into that container. You take it and just put it aside, not putting it back into that container. So it says that Claudia will win the game when C draws the green marble. How many green marbles are there? Two of them are green marble. So what is the winning probability of Claudia to draw the green marble in the very first draw? In very first draw, if she able to pick the green marble, then it is two green marble out of total n marbles that we have. This will be the probability. And what is the probability that she wins in the second draw? It means in the first draw, the color she picked was not green. And in the second time, she able to pick the green marble. So what is the probability for non-green marble? Out of n marbles, we have two green marbles. So the number of non-green marbles would be n minus 2 divided by total number of marbles, which is n. And then multiplied with the green marble, which is 2 out of, since the marbles she picked first time, she will not going to pick it back. So the sample size is decreased by n minus 1. So she picked the green marble for the second times out of n minus 1 marble. So this is the probability for drawing the green marble in the second draw. Is it clear?
Yeah.
All right. Let's come to the next part. Now we have the value of n given. We have given like how many marbles were there in the bag. So it was 6 marble. Find the probability that game will end on her third draw and fifth draw. So it means that she able to pick the green marble in the third draw. So what was happened before third draw? In the first two draw, she would not able to pick the green marble. It means out of 6, how many non-green marbles are there? 6 minus 2. 4 non-green marbles are there, isn't it? So first time she draw 4 out of 6. Second time she draw, since she picked the marble in the first time, she will not going to pick it back. So it will be 3 out of 5. And then she able to pick the green marble, which is 2 out of 4. So what is the result? It is 1 over 5. Come to the part 2. She able to pick the green marble on the fifth draw. It means in the first 4 draw, she wouldn't able to pick any green marble. So the probability would be 4 out of 6 times 3 out of 5 times 2 out of 4 times 1 out of 3. So these are the probability for choosing non-green marbles in very first 4 attempt. And the fifth attempt is able to pick the green marble, which is 2 out of 2. Because then the bag will have only 2 green marbles. What is the result? It is 1 over 3 times 5. This is 1 over 15. Is it clear?
Yeah, I got it.